This is the first installment on a two-part series that has to do with operator overloading in Python. This is a common theme in object-oriented programming, so it's a neat topic, and hopefully we'll learn something here. Alright, so I've set up in a class an employee. It's a very simple class. Employee has a last name, first name, email. These are optional parameters, and if they are none, then we input the last, first, and email. Okay, so I only checked if the email's none. If the email's none, I'm just assuming the last and first are also none. If I was deploying this in a real world situation, then I might do something about checking those, but for this video this will work fine. And otherwise, if these parameters are passed in, I just set these attributes for the class, last, first, and email. And then I have a string method for the class that allows me to print an employee out that just prints their last, first, and email on a new line for each one. There's a little menu. This is a function. This is not a method. This is outside the class. So there's a menu function that prints out the options of adding an employee, listing the employees, or quitting. And it asks you to type in your choice. Then we check to see if that choice is an integer or not, and if it's in between 1 or 3. And if none of those things happen, then we go back and we call menu again, and we keep getting that choice until we get a choice between 1 and 3, and then we return that. Okay, so down in the main menu, or the main part of the program, we set choice. We call menu to get our choice. Maybe or maybe not, we should have, use the same variables here. This choice variable is different from this one. This is local to the menu function. This is out inside the main program, so there are different variables, although we end up setting this one equal to this one via the return. Anyways, so we go get the choice from menu. This is pretty standard. We've seen a lot of this before. I don't think there's anything new or surprising here in what I've done. We have a list of employees, and then while the user hasn't chosen quit, which is 3, then we append an employee, which adds to our employee list, and then we can print the employees. And notice that I've had an employees.sort here commented out, so we'll get to that in a minute. And then we ask for the choice again, and we just keep doing this loop until you choose to quit. Alright, so I'm going to run that. It didn't do... That's interesting. It says it's running operator over... Oh, that's operator overloading 4. Let's try this. There we go. Alright, so I was running the wrong program. Let's add an employee. So we're not going to get fancy with employee names here. So we'll have D, D, D. We'll add another employee, D, and this time we'll have a first name of A and D. Notice I didn't check the email address for correct formatting. This is not what this program is about. I'll add one more employee, A, and I'm going to list the employees, and when I list them, they're listed in the order that I put them in, which may not be what I want. I may want them in alphabetical order. So I'm going to rewrite the program to add a sort. Now this is this is an inline sort procedure that is built into Python for lists. So any list can call sort, and you got to be careful when you do this because it sorts the list you have. It doesn't make a new list. You don't say new list equals. You don't say new list equals your list sorted. That's not how this works. It actually sorts the current list that you already have. Okay, so excuse me. Let's run that and see what happens. So I'm going to add employee again. Same ones that we had before. list the employees, and we run into a problem. So in order to sort this list of employees, it has to know how to compare to employees. In other words, it needs to know when one employee is less than another. All right, this is where we get into operator overloading. So this over here, operator overloading 2, has much of the same code as operator overloading, and we have the init method, which is no different, the string method. But what we have different here, everything down here is exactly the same as before. The only difference in this program is we are defining what the less than operator means. So overloading in this case means that less than traditionally has been defined in terms of numbers, and then we extended that to letters and strings so that we could alphabetize things, and now we're extending it to employees. So we're overloading the less than operator, which means that we could, with this operator, ask questions like this. All right. Well, actually, I'll put more down below in terms of less than. So the format for less than is the double underscore and LT double underscore. Now this is a little bit different. Notice that when you define the less than operator, actually I'll type it out, it automatically comes with a self and another. This other variable, the assumption here is that you're comparing two things of the same type. And in the next video we'll talk about what happens if they're not of the same type, but that's for the future. So for right now we're assuming that we're comparing two objects that have the same type. The first one, the one on the left, is self, and the other one, the one on the right, is other. So we could say something like emp1 less than emp2. That should return true or false, and in our code here this would be self and this would be other, and these would be both of type employee, class employee. Alright, so when is this going to be true? When is self less than other? Well, if the last name is a string, I actually didn't say that right. The last name is a string, and so if we compare the two last names as strings, if self's last name is less than other's last name, then you're done. We alphabetize by last name first. Or if they're equal to each other, the last names, then we check to see if the first name's self's first name is less than others. And in either of these two cases, in the first case where self's last name is less than other's last name, or their two last names are equal and self's first is less than other's first, we return true. In any other case, self is not less than other. So what kind of possibilities are left? Well, they could have actually the same last name and same first name, but in that case, self is not less than other. In some ways, I guess they would be equal to each other. So think about, this covers all the cases where self is less than other, and so this is the only place where we return true, and then here we return false. And like I said, down below, everything else is the same. We have the menu. We run the while loop. The only thing I've done is I've uncommented the employees.sort, and then we're going to print the employees out. Just as a quick review, remember this is a list, so we can do a for loop through the list, and each employee has a string method, so we can go ahead and call print with those, and we'll run this, and we'll add an employee. So we said D for an email, add another employee, D. I just screwed up. Well, okay, we can do that. We'll add another employee. How do I do this? DA. I'll put in C for their email, and we'll add one more employee, A. And now we will list the employees. I'm going to need a bigger screen for this. And when we do, notice that they are listed in the order we would expect. A comes first, then all the rest of these have the same last name. This one, the first name A is less than the first name here. In these two cases, the names are equal, but sort doesn't worry about if they're equal. It just doesn't change their order. Let's check that. So let's see, what order did I put these in? Yeah, I put this one in second compared to that one, and it stayed that way in the list. And you might ask, what happens if you add something with a little more length to it than just A, or D. So we could do the Jim Bob family. Don't care about their email. Notice that when I did the comparison, when I could define less than, I didn't do anything with the email. So this is one of the things about defining your own operators. You choose which of the attributes in your class are used for defining less than. We'll be talking about equal and greater than and other things. So when you're defining these operations, you're the one that decides which attributes get used to make them work. Alright, so let me add another employee. We'll have another member of the Bob family. We'll make it Jane. And we will list them again. And we will see that Jane Bob becomes before Jim Bob. That actually doesn't have anything to do with, well, I mean, a modest amount of what we did with overloading the less than operator for our employee class. What that really has to do with is comparing two strings. So when we're ordering Jane Bob versus Jim Bob, it compares their last names as strings, finds that they're equal, then compares their first names as strings, but the string class already has a less than or equal to overloaded operator, which we've seen before. Works like a dictionary. So that's already implemented, and this comparison here will call those overloaded operators for strings. Makes the comparison, gives us a nice sort. Alright, so from here I'll be making another video to show a little more operators that we can overload, and we'll be making a date time class.